Optical illusions have intrigued humans for centuries, captivating us with their ability to distort our perception and challenge our understanding of reality. These visual tricks can make us see things that aren't there, misinterpret sizes and shapes, and even perceive motion in still images. But what makes optical illusions so fascinating, and what is happening in our brains that allows these illusions to occur? Optical illusions exploit the way our brains process visual information. When light enters our eyes, it is converted into electrical signals that travel to the brain, where they are interpreted to create the images we see. This process involves complex interactions between our eyes and various regions of the brain, including the retina, the visual cortex, and other higher-order areas responsible for interpreting and making sense of visual input. Optical illusions can be broadly categorized into three main types: literal illusions, physiological illusions, and cognitive illusions. Literal illusions. These illusions create images that are different from the objects that make them. For example, the famous duck-rabbit image can be seen as either a duck or a rabbit, depending on how you look at it. Physiological illusions. These illusions are caused by excessive stimulation of a specific type, such as brightness, color, movement. An example is the Hermann grid illusion, where dark spots appear at the intersections of a white grid on a black background. Cognitive illusions. These illusions arise from unconscious inferences and are often more complex. They include ambiguous, distorting, and paradox illusions. The Penrose triangle, an impossible object that can be drawn but not physically constructed, is a classic example of a cognitive illusion. Our brains are wired to recognize patterns and make sense of the visual world quickly and efficiently. This ability is essential for survival, helping us identify threats and navigate our environment. However, this same efficiency can lead to errors in perception, which optical illusions exploit. Firstly, pattern recognition and expectations. Our brains are constantly making predictions based on previous experiences and context. Optical illusions can manipulate these expectations, leading us to see things that aren't there. For instance, in the classic Muller-Lyer illusion, two lines of equal length appear different because of the orientation of the arrows at their ends. Secondly, context and contrast. The brain interprets visual information relative to its surroundings. This contextual processing can create illusions of size, color, and brightness. The checker shadow illusion, where two squares of the same shade of gray appear different due to surrounding shadows, demonstrates this effect. Lastly, neural adaptation. Prolonged exposure to a particular stimulus can alter our perception. In the case of afterimages, staring at a bright color for an extended period can cause the brain to see the complementary color when looking away, due to the temporary exhaustion of the photoreceptors in the retina. Optical illusions captivate us because they reveal the inner workings of our brains in a tangible way. They highlight the complex interplay between perception, cognition, and expectation, showing us that what we see is not always an accurate representation of reality. This glimpse into the brain's processing mechanisms can be both enlightening and humbling, reminding us of the limits of our perception. Moreover, optical illusions are a form of visual art that challenges our minds, sparking curiosity and wonder. They encourage us to question our assumptions and explore the boundaries of what we know about vision and the brain. Optical illusions are a testament to the incredible complexity and adaptability of the human brain. By playing with our perceptions, they offer insights into how we interpret the world around us and demonstrate that our reality is, in many ways, a construct of our minds. As we continue to explore and understand these fascinating phenomena, we not only learn more about optical illusions, but also gain a deeper appreciation for the intricate workings of our own brains.